Good morning, everyone. Well, good morning for me. Good afternoon or good evening, or wherever you are. My name is Sam. I'm going to walk you through my presentation on how to build a robust data pipeline with what I call the DAG stack, DBT, Airflow, and Great Expectations. I'm going to give it, actually, I'm going to start with intros. I see there's still people coming in, but I'm just going to get started because I have a lot of material. So first of all, hello again. I'm Sam. Thanks so much for actually using my title. I have a PhD in computer science. I'm a data person, I guess, and former engineering director at Superconductive. So actually, as of last week, I'm no longer with Superconductive, but I spent a year working on Great Expectations, which is an open source data quality and documentation tool. I'm from Germany, in case you're wondering where that accent is from. I know people are always very curious about that. I'm currently based in New York City. In fact, right now, the reason why I said good morning is because I'm in Hawaii. I've been for a few weeks to escape the New York City winter. You can find me on Twitter at spbale, and you can also read out my blogging on sambale.com. So first of all, welcome to what I call the DAG stack, DBT, Airflow, and Great Expectations. In terms of the structure of this talk, I'm going to talk about, just give a brief introduction to what all those tools actually are. Then I'm going to do a deep dive on the definition of the word robust. So I'm going to talk a little bit about testing, and then I'm going to show you how this all fits together. Just a minor disclaimer, I am on a slightly older laptop, and on a single screen. So just in case things are lagging a little bit or things are a little slow, I'll get a ping hopefully from the host, and I can switch things over. So in terms of the key takeaways of this is really basically if you're fairly new to DBT, Airflow, Great Expectations, any of those tools, or if you've sort of been dabbling but wondering like what's a good way to put them together, this will hopefully give you an idea of how to connect all these pieces. And the second key takeaway is sort of the, I just want to make a case for testing your data pipelines and give you some ideas of where to implement testing in your pipelines using those tools. All right, great. So we're going to start with DBT, brief introduction to DBT. It's been super popular, so I'm not going to spend too much time on it. If you're completely new to DBT, I hope this gives you a little bit of an overview. If you already know about DBT, this is probably going to be nothing new. So DBT stands for Data Build Tool. They call themselves the T in ELT. So the transformation step in the extract, load, transform, or ETL, or reverse ETL, ELT, whatever you want to call it these days. In your data pipeline, it's specific for the transformation step. It's an open source Python package, which is really cool. They have a paid cloud version too, and it allows you to write a data pipeline as a series of templated SQL nodes. I'm going to show an example of that to show you what that means. But basically, it allows you to write a data pipeline using the language that most analytics people, for example, already know, which is SQL. And all the operations are executed on top of a database that you already have, that you've loaded your data to. So it's really, it really kind of does the one thing, and it does it really well, which is doing SQL operations. I kind of like to say that DBT is a really fantastic way to split up huge SQL scripts that you have that are sort of like spaghetti code, and it allows you to structure it nicely in what they call models. I just call them nodes in the DAGs, the nodes in the graph, that allows you to structure and have better monitoring, better visibility into what's going on in each individual logical step, rather than having one big SQL script that just sort of like breaks somewhere in the middle. Does that work? Okay. So this is some sample code. I'm going to be showing a bunch of screenshots. Again, I'm on a little older laptop, so there won't be a live demo today. So this is really straightforward. This is what I meant by templated SQL code. So basically, all you do is you write your standard SQL queries, and then instead of referencing tables directly, you basically just use a little bit of Jinja and reference the names of the models, which is basically just the SQL files that you have in there. And that allows you to build up a dependency graph that dbt parses out and then executes in the correct order of the dependency. As you've just seen on the previous slides, it builds up this nice little graph and then just executes everything in the way it's supposed to be executed, which is super, super helpful. So you don't have to do a lot of thinking as to like what comes first, what comes next, what comes next. You just write your queries in your pipeline in the way the business logic makes sense. This is just a screenshot of what it looks like when you run dbt. So you literally just call dbt run after you've installed the package, and then it executes all the models in the right order, and it tells you whether it's completed successfully or not. The other cool thing that comes with dbt is you can generate pipeline documentation, so it allows you to add a bunch of even markdown, for example, to describe each individual model. So you have inline documentation. You can describe every single column in there. You can add tags to each model, which allows you to just write to run subsets of your DAG. So there's a lot of like very nifty sort of small tools that help you to actually understand better what's going on in your pipeline and sort of document it. And the other thing that comes with dbt, which is what I'm going to talk about a little bit more later on, is testing. So dbt also allows you to add tests to a pipeline, which means you can, for every column, for example, you can assert that a specific column should be, in this example, I think I'd say not null, for example. So not null trucks with bar name. So you can say a column has to be not null. A column has certain accepted values, so it actually checks for a list of values, whether they're in that column. You can enforce uniqueness, lots of different things that are built in already. And then you can also just write custom tests. Anything that you can express in a SQL query, you can basically express as a test in dbt. So this is super cool. dbt is sort of like an end-to-end tool again for your transformation steps in your pipeline. The thing that it doesn't have, at least in the open source Python package version, is built-in scheduling functionality or functionality to just run arbitrary code that's not SQL. So anything that relates to, for example, your load step, your extract step, any sort of more complex operations or calculations that you want to do in Python, any of your, if you want to run any of your ML models or anything like that you want to kick off in your entire data pipeline, you won't be able to handle with dbt. So if you want to include other building blocks in your data pipeline, you need something else. And that something else could be, for example, Apache Airflow. I'm really just using Apache Airflow as an example here because that's the tool that I'm most familiar with. I think it's also pretty much the biggest and most popular workflow orchestration tool out there, at least in the open source space. There's a ton of other tools that will that are sort of becoming more and more popular that accomplish the same thing. Airflow just seems to be the sort of go-to at the moment. And to be fair, like a lot of the other tools kind of looked at Airflow and said, okay, Airflow is cool, but there's some things that we can actually do better. So Apache Airflow is a workflow orchestration tool. It's another open source Python package, so everything I'm talking about today is open source. I like to call it, in a little slightly mean fashion, it's cron on steroids. It can do scheduling, but it can do a lot more. So imagine you have, back in the good old days when you would run a data pipelines, and I'm sure a lot of people still do that in production. I've definitely worked on a team where our production pipeline was kicked off by a cron job every day. Basically, you would have your cron tab that has your jobs in it, and then you have some shell scripts that just trigger all the different parts of your pipeline, or it might be a Python script that kicks it off. But basically, Apache Airflow just takes care of that. It provides a nice UI. And the fun thing is, again, it builds another DAG. So we're on our second DAG, our second directed acyclical graph. So it's just another graph that's being built up out of the individual nodes, which in this case are called tasks. So here's an example of a very, very simple Airflow DAG where you basically have node or task number one right at the start. So let's run this first. Then you have once that's run, you can have another task. You can do branching, so you can have multiple things run in parallel. You can have joins of branches. So it kind of allows you to do, build up fairly complex DAGs. I'm getting a notification from GoToMeeting. Sorry, 1 second. Just wondering what's going on. Do we have any issues here? Oh, Q&A link. Okay, thanks. That was just a link to the Q&A. So I hope everyone can still hear and see me. Okay, so yeah, this is what you can do with Airflow. And the nice thing is that you have full control over every single node. So you can see which task failed, which task succeeded. You can have logic in there that you want to continue running your DAG if any of the node fails, or that you want to just completely stop execution of this. So you have very fine-grained control over what you want to do with this. And so how does this fit in with DBT? How can we trigger DBT as part of an Airflow DAG? You can simply run DBT, so a DBT pipeline as a task in an Airflow DAG. So if you think back to the initial screenshot that I showed of DBT, which is a DAG right on the blue background, you can fit that entire DAG. You can just kick that off as a kind of like a sub DAG in Airflow. So Airflow allows you to really just run any task. It could be Python code, it could be a shell script, it could be pretty much anything. So you can just kick off anything like a DBT pipeline in there, for example, too. Just as a disclaimer, I'm going to show one pattern of fitting a DBT pipeline into a DAG. There's also a way of mapping every single node or every single DBT model that you have to its individual Airflow task. That's also a pattern that's totally valid. I have some additional resources in the GitHub demo repo you can read up. But in this case, and in this particular example, I'm treating the DBT DAG, DBT pipeline as a single task in the Airflow DAG. So just in terms of if you haven't seen a an Airflow DAG yet, this is kind of a really small snippet of what a DAG file could look like. So this is just a Python file, Python script, where you define your DAG, you give it an ID, and then you can run tasks. So you define each individual task using what's called operators. And you have, again, bash operators, Python operators. You can have a DBT operator. You can have we have a great expectations operator. So there's an operator for pretty much anything right now, and that just turns into a task in the Airflow DAG. So super straightforward. And like I said, there are other patterns to map DBT DAGs to Airflow. All right, so that was DBT, Airflow, and now I'm going to talk about Great Expectations. Again, as a disclaimer, I used to work for Superconductive, which is the team behind Great Expectations. So this is the tool I'm definitely the most familiar with. All the other DBT, Airflow, I just happen to be a user. Great Expectations, I actually contributed some code to the code base. So what's Great Expectations? It is yet another open source tool. It's an open source data validation and documentation tool. And it lets you express what you expect from your data. So there's going to be a lot of expect and expectation puns in this presentation. So Great Expectations that lets you express things like the values in this particular column in my data set must be between 1 and 6. And then you can test any kind of data that you throw at it. The sort of, I think, main use case that we're thinking of is periodic, so recurring data loads, data load steps, or data deliveries, for example. So let's say you extract data from a third party like every night or every month, and basically you know exactly sort of what the parameters are for this for the data set that you're receiving or that you're ingesting, and you want to just make sure, like, the data meets your expectations in terms of, for example, the number of columns that it has, the number, like roughly the number of rows, the distribution of different values, the ranges of values, things like that. So, and then you can basically run it against, month one, delivery one, it passes, the next month it fails because something is wrong with your data. We're all familiar with that. And then again, at some point it passes again once the data has been fixed. So this is kind of like the principle behind Great Expectations, is that you run sort of your tests periodically on new data that's been ingested. Just to dig a little bit deeper into what's an expectation. So an expectation is a statement about what we expect from our data. You can think of it as a test, a unit test, and it can be expressed in code. So in this particular case, in Great Expectations, you really just write like a little Python snippet, a little Python function call that defines that you want values to be between, and then you say which column, and you say the min and max value. This gets stored as JSON on disk. So you can have it under version control, and you can have it loaded by any kind of system that you want. And it can also be translated into human readable format for what we call Datadox. So that's the documentation output. Some people call it data quality report. I'm going to show a screenshot of that in a second too. In terms of your typical Great Expectations workflow, I've already kind of mentioned that, but I think it's sometimes not super clear that it's sort of like a 2-3 step process of creating an expectation suite. So step number one is create an expectation suite. There's different modes to create an expectation suite. It's either suite new or suite scaffold. So suite new basically just means you write your expectations manually, so you know something about the data already, or you've done some EDA, some exploratory data analysis, and you kind of know what your data should look like, or you're working with a subject matter expert and you're basically just writing out those statements that you know should be true about your data. The other option is to scaffold an expectation suite, which is using a profiler. I'm going to talk about that in a second. And then you save that expectation suite. So that expectation suite is your suite of tests. A and B is also your documentation about your data, right? It basically tells your users, this is what the data should look like. This is what we expect the data to sort of the properties that the data has. And then we kind of go into this loop of validating data and responding to validation results. So the idea is that step one, like creating your expectation suite, you kind of do it once. Obviously, you can go back and tweak it, right? That's part of like a normal workflow. So you can imagine a little bit of a dotted line over to one. But the idea is that you create your definition of what your data should look like, and then you use that in production to validate any kind of incoming data. So you load the new data, you load your expectation suite, and then you run validation. And then step three is you respond to validation results, right? Which is either you stop your data pipeline completely if something went wrong and you want to not even continue processing because your data is so messed up. You can send alerts, you can send notifications to Slack, you can send emails, pager duty, for example. And then the last step will be to build and expect Datadox. Again, I'm going to show that in a second. So just to kind of give you an overview of sort of the typical flow of this two-step process. A little bit more about automatic profiling. So profiling is really cool because it basically just means you don't really have to know that much about your data. Obviously, I'm not claiming that you can just like write perfect tests without knowing anything about your data. You always have to, understand your data fairly well. But profiling kind of can help you create those expectation suites so you don't have to start from scratch. The idea behind profiling is pretty straightforward. You just take historical data. You run a profiler that looks at this historical data and gets things like, okay, for this column, how often is it actually null? Or how often, like what's the range, what's the min and max range of the values in this column? What's the distribution of those values? So it gives you a lot of basically descriptive statistics about it. And then based on that, infer some expectations. And again, I'm a very firm believer that there always needs to be some amount of domain expertise or human sort of control to look at it and say, okay, yes, this makes sense. Or, well, actually, maybe this is already wrong in our historical data. Like we shouldn't have this as an expectation. Or, well, this is kind of right, but we actually want to loosen up the restriction, or we want to add an additional restriction here, for example. And then using this process of profiling and scaffolding, you get to your expectation suite. And then you can use that expectation suite to validate any kind of future data. So this is really funny. In the process of creating the demo repository for this talk, I started using just like writing my expectations from scratch. And at some point I was like, okay, this is a lot of work. I'm just using a scaffolder, and Great Expectations actually just released a new, more configurable scaffolder the other day. And it actually works really nicely to create pretty reasonable expectations to start with. Pretty basic, but reasonable. Okay, and then the final thing I want to show for Great Expectations, what I've been talking about, is Databox, which is basically, like I said, some people call it data quality report, which basically just tells you the expectation itself. The expectation values must always be between 1 and 6, and it tells you whether that passed or failed, and if it didn't pass, it tells you why. So it says, like, here are some of the unexpected values that we didn't expect in here. Cool. And this is how Great Expectations would fit into an Airflow DAG. So you have, there's actually a Great Expectations operator. Again, this is basically just a wrapper around, a few lines of Python code. So if you want to just run this as a Python operator and then run the actual validation of Great Expectations manually, that's also perfectly acceptable. But the Great Expectations operator provides a little bit of convenience, a little bit of abstraction. Basically, all you do is you give it the assets to validate. So in this case, you give it, here I'm validating my source data, my CSV file. So I'm just giving it the path of my CSV file, and I'm giving it the expectation suite name. So I've created an expectation suite called taxi zone source and taxi trip source, where I'm just asserting certain things, like, for example, the number of columns in there. And that's it. And then Great Expectations just runs validation at that step in the DAG. Okay, so just to recap, I've talked about DBT, I've talked about Airflow, I've talked a little bit more about Great Expectations. So this is sort of the whole package, all the individual components of that stack. In the second part, I'm going to talk, not very long, but I'm going to talk about testing and why you should test your data, because technically you could just go and build a wonderful data pipeline with all these tools, not test your data at all, and you'll probably end up with a garbage in, garbage out kind of situation. So let's do a deep dive into testing, into the robust part of this talk. All right, you should test your data. Please believe me. If you don't think you should be testing your data, come and talk to me after this, and hopefully I can convince you, or maybe the following statements will convince you. So these are things that we've actually heard from Great Expectations users that said things like, our stakeholders would notice data issues before we did, which really eroded trust in the data and our team. If you have been in a data role where you provided dashboards, for example, or analyses to your users, this probably sounds very familiar to you, where you constantly have data fires, or the data is stale, or something is off, or something just goes unnoticed for a while, and your users will just become increasingly unhappy. Another issue that's actually really interesting to call out, so we had another team of users say that rerunning data pipelines after finding a data quality issue would incur actual costs for the compute environment. So if you have a very heavy data pipeline where you actually pay for your compute to rerun it, that incurs actual costs, right? Obviously, in the grand scheme of things, maybe that's not huge, but it'll probably add up, and it's something that you have to explain, right? And it's something that you can prevent by having tests in place and not running your pipelines just spuriously. And this is sort of the worst case scenario, the one Thanksgiving where we worked all weekend to fix those data issues that we only noticed at the last minute. Never again. That was me. I had one Thanksgiving where my entire team was working to get a data delivery, end of the month data delivery out in time, and we noticed a quality issue that we tried to fix all weekend. So it also contributes really to team burnout, team unhappiness. The data teams that have to just fight fires all the time, they're definitely not the happiest. All right. So now hopefully I've given you some ideas as to like what the kind of issues are that you can prevent by having good testing. But the question is like, where do we start, right? Which tool should we use? How do we know we're testing the right thing? What do we do when test fails? Who owns this? How do we keep the test up to date? How do our stakeholders find out about the state of the data? So tons of different aspects here. I'm not going, this is a talk in itself. This is an entire separate talk. I'm just going to give you sort of the technical pointers as to like how you can implement tests in this dbt Airflow Great Expectations type pipeline. So yeah, again, data testing is hard. I can show you where to get started. The main sort of statement that I like to make when it comes to like when and how should I test is test your data whenever there's a handoff between teams or systems. So by that I mean, so by systems I mean, for example, when you're loading data from, let's say, a CSV file or some other database or wherever it is from a production database or like a third party into your system, that to me is a handoff. That's actually a handoff both between teams and systems. When you do transformations, for example, that is, and once you're done with your transformation and the data goes into, you know, wherever your data warehouse and, you know, another team like the data science team uses it, or it goes into a dashboard or whatever happens with it, that's another handoff, right? So whenever there's a little bit of a, like a transformation step, or another team uses it, or you're loading it or putting the data somewhere else, you should probably test to make sure what you've done is actually correct. Here's an example of the types of sort of handoff steps that I'm talking about. So this is basically just a, you know, abstract version of a DAG, of an Airflow like pipeline. So we have a source data load, and we'll probably want to validate that the source data is actually correct. If the source data is correct, if it matches what we want to do, okay, well, we'll load it. We extract it to a staging environment or reload it somewhere, right? Then we want to make sure that the loading is actually correct. So we didn't just drop rows or garble any of the like formatting, for example, when we loaded it. Then we do the data transformation, and we want to make sure, obviously, that our transformations were correct, and we didn't just like mess up the code, for example, and do something completely wrong. My favorite example, my favorite thing that I always do is when you join incorrectly and you on like non-unique keys, for example, across database tables, and you cause a fan out, and all of a sudden like the number of rows like doubles. That has definitely happened and gotten unnoticed. So that's the kind of validation that you want to do there, for example. And then finally, you can like promote it to production, which means data warehouse, or again, like a production database, dashboards, et cetera, et cetera. So I hope that has given you a little bit of a sort of more abstract idea of what I mean by, you know, handoff. All right, final stage, putting this all together. So again, dbt, Airflow, Great Expectations, testing. How do we do this? How do we smoosh this all together? I have a demo repository that's live on GitHub that actually contains a running, like a working example as a disclaimer. So we can, instead of saying DAG, we could also say DAG with a double A, because in this particular case, I'm using Airflow through a tool called Astronomer. So if you see in the top left here, you see this little .astro file or directory. The Astronomer is, oh my goodness, Pete is probably going to hate me for butchering this, but I would call it like a very smart Docker wrapper around Astronomer, or around Airflow, or containerized Airflow. So Astronomer just like takes care of a lot of the Airflow configuration, and you can, it's again another open source tool that has a paid version. But it's a very nice way to run Airflow in containers, where you really just hit Astro start, and it just spins up all the scheduler, the web server. It spins up a backend database, so it does a bunch of stuff for you, so you don't have to do it. And the nice thing is, because everything's containerized, your development environment is basically, you can just push that up to wherever you want to run stuff in production and just deploy it really easily. That has been one of, I think, the biggest issues with Airflow development is local development versus production deploy. So anyway, so that's Astronomer, just in case anyone's curious or looks at the demo repo and is wondering what's going on there, what's all the Docker stuff in there. So this is just a snapshot of the directory, what it looks like. So we have my DAG file for Airflow. I have a DBT directory that has all my DBT models in there, and I have my Great Expectations directory that has all my expectations. For what it's worth, Great Expectations also allows you to store all your stuff on like S3, for example, or some other cloud stores. So you don't necessarily have to have anything in those local directories. But I'm just kind of doing like a default setup here. This is what that particular DAG looks like in the Airflow UI. So as you can see, I have a very neat graph here. And again, it starts with validating my source data. In this case, I have a bunch of CSV files that I'm validating. I'm running dbt seed to load the data into the database. I'm validating that the load was done correctly. Then I'm running my dbt pipeline, so a bunch of just a really small pipeline with like a handful of models. Then I'm validating my transformations. Then I'm generating my documentation both for dbt and for Great Expectations. As I've already shown, like both of these have docs. I'm copying them over. In this case, I'm just for the demo, I'm just copying this locally to a directory that's mapped from the containers onto my host machine. In production, you would probably move this to, again, like S3, for example, where you can actually serve the docs from, but this is really just a dummy copy step to kind of show that you can copy the files. And then I'm loading it to prod, whatever my production database is. So this is a really nice little DAG. And then the last section, so again, how does this all fit together in terms of testing, in terms of robustness? I'm just going to show you how I test in all these validation steps, like what kind of tests I do. So first of all, testing my source data in a validate source data step. I test that my source data in my example CSV files actually match my expected format. For example, correct number of columns and correct spelling of columns. This is actually really fun. I recently worked with a NYC data open data project, and sometime in September 2016, the data file just changed the headers. Like they just changed the spelling of headers, and my pipeline blew up because I didn't, secure against that. So that is a nice way to make sure you're not breaking stuff, or you're, for example, quarantining whatever is going on there. Yeah, you can check correct number of columns, data types. You can check that the row count is kind of similar to the previous month, et cetera, et cetera. And those tests are implemented in Great Expectations. Again, with DBT, I operate entirely on my database. So anything that happens outside of the database, I have to use other tools. So in this case, I'm validating my source data with Great Expectations. Once it's loaded into the database, I'm also testing that the source data load was successful. In this case, for example, I can say no rows were lost compared to the source. The headers that I have are still the same. The thing that I'm doing here in my demo repo, which you might notice, which is kind of cool, is I'm just reusing the exact same test from my validate source data step, because I expect the data to be exactly identical. Obviously, if there's any kind of transformation or massaging or dropping columns or whatever it is that you're doing in the load step, that won't work. But in this particular case, because I expect the data to be loaded in the exact identical way, I'm just reusing the same expectation suite here, which is kind of fun. One real cool thing that you can do with DBT is you can run tests during the development, and you can also totally do that with Great Expectations. I really like having those sort of like straightforward tests in DBT while developing the pipeline to, for example, check for nulls, to check for uniqueness, et cetera, because the dev loop, the turnaround there is just much faster. And it allows you to write the test like right into the DBT pipeline, and you can run it during development. And then the last step, once you've run your data pipeline, is to test the integrity of the transformations. So again, no fan out joins, no null columns, et cetera. You can do that with DBT, or you can do that with Great Expectations. So for Great Expectations, it has some off-the-shelf methods for very complex tests and things that you might not want to write in SQL or that are very complex to write in SQL. For example, things like distributions of values. So people always ask us, should we use DBT or Great Expectations for testing? Again, outside of the database, it is very clear that you have to use another tool. You can't use DBT. For stuff that runs in the database, it really depends on sort of the purpose and what you want to do with it. It also depends on whether you want to have like Datadox, for example, to also cover every single step there. And then finally, yeah, that's it actually. Sorry. So wrap up. As I said, Airflow, DBT, Great Expectations, a modern data pipeline stack with built-in testing capabilities. Again, I'm also throwing Astronomer there, just because I find Astronomer super convenient to use. All you have to do is set up Docker, install Astro, and you're ready to go, so you don't have to mess around with Airflow and dependencies and stuff. Second, in terms of the robustness, in terms of testing your data, test your data whenever there's a handoff between teams or systems, as I've shown you. And then in terms of what to use for testing, use DBT or Great Expectations depending on what data you test and where your data lives and the required complexity of your test. Again, I'm not necessarily saying that DBT can't handle complex tests. It can totally do that. I sometimes hit the limit of what I want to write in SQL, and I find it more convenient to either use built-in methods in Great Expectations or write custom Python code for that. And that's it. So we have a few minutes left for the Q&A. I believe I will exit out of this and go into the chat. So this is my GoToMeetings. Okay. I'm going to stop sharing my screen. I don't know how that works. Sharing. Stop sharing. All right, back. Okay, so I'll jump over into the chat, into the Thursday, Sam, Bale, building a robust pipeline, yada, yada, yada. And I can answer questions for 4 more minutes. So we had one question from Gideon asking, how does it work with data in JSON format or when extracting data from the source using an API? Was that, are you talking about the pipeline in general or DBT or Great Expectations specifically? I'm going to just answer the question and say, like, for the pipeline in general, if you want to use DBT, it will have to be in a database, in a relational database. So what you want to do is have a load step. So as you might have seen, like I've used DBT seed in a load step, which is really just a very convenient method for loading CSV files into your database. In the same way, you could just have like a Python snippet, for example, that loads your JSON into your database in whatever like format and schema that you want. So, and the same way when you extract data from a source using an API, I would say there's a little bit of Python code. There's a node in your task in your Airflow DAG that does that extraction and then loads it to your database, and then you can run DBT with that. So that is a fantastic use case for, or a fantastic example of what I said when I said like anything that happens sort of outside of the database, you'd have to use another tool other than DBT. So that's a great example for having Airflow in there. Mark asked, how does Great Expectations behave when scaling out computation to large data sets? That's a great question. I think the answer is it depends. It really depends on the back end. I am actually not aware of any like benchmarks that have been done. I would say test it out. I think that's my answer, where I basically just say I'm not super familiar. I know it works on fairly large data sets, but again, the question is like, how large is large for you, right? Like how many million rows or thousands of rows. So it really depends. I think if you're doing it, like if you're actually just operating on a relational database, it should be pretty fast, or any other backend that's supported by it. if you're running things on like, if you're testing a pandas data frame, obviously there's some limitations there. I see someone else typing. Any other questions? And I'll be in the chat for like after the talk too, so we can continue chatting there when I get the timeout sign for this talk. Okay, so James asked, what are benefits of using DBT rather than an Airflow SQL operator with a template search path to allow for SQL files? That's a great question. I think I just really like the built-in tooling in DBT that does the Jinja templates that automatically builds up your dependency graph for you, which means you can kind of just write the SQL queries as you would, just like wrap them in the curly brackets, and you don't have to worry about am I executing this first? Am I executing that first? Am I executing that first? You don't have to worry about the order of execution and all the dependencies. I think to me that is probably one of the nicest features. And again, you have the DBT test, so you can like very easily write tests and everything. The other thing is you can also just run your DBT pipeline in isolation. So DBT kind of use the term analytics engineer. So the idea is that you have people who might not necessarily want to run Airflow locally, people who are non-engineers, people who are really good at writing SQL, but don't necessarily want to run like the entire thing, but just focus on the transformation steps. So that's also a benefit that your team can focus on like writing a really good pipeline. They see the results, you can write the tests and everything, and I don't necessarily have to worry too much about the entire infrastructure of it. So I think that's also a benefit. Again, to me, being able to chop down any kind of large SQL query, SQL scripts into these smaller nodes where you have very fine-grained control over what's going on in each individual node / model is probably the biggest benefit there. Having said that, just a disclaimer, having said that, I actually think if you really just write like 1 or 2 SQL queries, if you have very, very little SQL in your pipeline and it's just a couple of queries, you might be better off just using the SQL operators. Absolutely. Like if it's something that's like not complex and where the dependencies aren't like particularly complex, and you just write a couple of SQL queries, yeah, I think writing SQL in Airflow is perfectly acceptable. I think we're at time for the this talk.